In this short video, I will demonstrate how to solve a sequential move game when a game tree has been provided to us. So let's consider the following game. I want you to notice that we have player A acting first. They choose either high or low. Player B then observes what player A has chosen, and they can choose either up or down. Then we have the payoffs over here, and they're organized A, comma B, which means the red number is the A payoff and the blue number is the B payoff. Our goal here is to solve for the equilibrium. We know that sequential move games, like the one depicted here, are always solved via backwards induction. That means that we need to start at the end of the game and figure out what player B would do at each decision point. So let's first start imagining they're sitting right here. They've observed that player A has chosen high, and they have a choice. They can go up or down. If player B chooses up, they'll get 12. If they choose down, they'll get 16. So they're comparing this to this. 16 is clearly preferable, so I'm going to highlight this path to indicate that that's the path that they would follow if they found themselves at this decision point. Now we do the same thing down here. If instead player B finds themselves observing that player A has chosen low, they have two options. They can choose up, in which case they'll get 4, or they can choose down, in which case they'll get 3. Clearly, 4 is bigger than 3, so this is the path that they would follow if they found themselves at this decision point. So we've figured out what our follower is going to do, and now we're going to back up through the game and determine what our leader, player A, should do. So player A knows if they choose high, then player B will choose down, and they'll get 9. They also know if they choose low, player B will choose up, and they'll get 10. Well, 10 is clearly bigger than 9, so player A chooses low. The equilibrium is where the paths connect, so to speak. So we could say the following. The equilibrium is for player A to choose low and player B to respond by choosing up. Let's add a little fun to our story here. Suppose that player B is considering the following threat to improve their payoff from 4, which is what they get in equilibrium that we solved for previously, to 16. They claim, I will choose down no matter what player A does. So I'm going to highlight what their claim is going to be so we can understand why they might want to try and make this claim. So they claim they're going to choose down no matter what. If player A believes this, now player A says, okay, if I choose high, I'm going to get 9. And if I choose low, I'm only going to get 7. So they like that 9. And the result is that they would choose high, and it would be really great for player B because they would get 16. And without this threat, the equilibrium was low up, and they only got a payoff of 4. So this is the plan that player B has laid out. They're like, I'm so smart, I'm going to make this threat. I am only going to play down. And by doing so, I get $12 more payoff. The question we want to answer is this a credible threat? Sounds like a great idea, but is it credible? In order for a threat to be credible, you would have to actually follow through with that threat if you found yourself off the equilibrium path. What I mean by that is, they're claiming they're always going to choose down, but if they actually found themselves sitting at B, yes, they would follow through, right? So that sounds good so far, but if instead they were sitting down here, so player A responds in a way that they don't want them to and chooses low, player B would never follow through with this threat and choose down, because if they did, they would get 3 instead of 4. So it's an empty threat, because if they're pressed, if they actually land at that decision point, they're going to be like, never mind, I'm not going to choose down because it's worse for me. So this is definitely not a credible threat. Player B would never choose down after observing low from player A. So the threat is empty and it cannot support this as an equilibrium. And we saw that that was not the equilibrium of this game. The equilibrium of this game was low up. So this is how you identify an empty threat versus a credible threat. An empty threat is one which you would not follow through on. In order for it to be credible, you would have to be actually willing to make that choice that you claim you're going to make. It has to be payoff maximizing.